Let's prepare on the shear force and bending moment. So before studying about the shear force and bending moment, let us see the types of supports. So there are three types of support. One is hinged and another one is a roller and the third one is the fixed. Okay. So the first one, let us see the roller support. So this is also called as movable hinged support. So what this type of support will be, how this will be, that means the horizontal movement will be allowed and the moment is also allowed, but the vertical movement is not allowed. So the reactions, that is the number of independent reaction, will be 1d1, that is in which side it can't move, the vertical side, no, so it will be the reaction, that is in the case of roller. When you see the hinged support, means it is only allowed to rotate. It can't move either in the vertical or in the horizontal direction. So the number of independent reactions will be 2. If you see the fixed support, means neither rotation nor translation, both is not allowed here, that is it can't move in the vertical and horizontal, and also the rotation also not possible. So the number of independent reactions is 3. So this is the very basics and you should be very clear with this. Okay, next, what is shear force and what is bending moment? So the shear force is nothing but it is the sum of the transverse force either to the left or the right hand side of any section. Okay, so if you are taking a simply supported beam and if you are drawing a section in the middle or somewhere, means you have to either consider the reactions left to that section or the reactions right to that section, the summation of those reactions. Okay, if there are one upward and one downward reaction, means it should be minus. Okay, so like that, the summation, the algebraic summation of the reactions in either left or the right will be your shear force. When in the case of bending moment, means it is the algebraic sum of the moments of all the transverse forces either to the left or right side. The same forces only, but you should multiply with the length so that you will get the moment. So the algebraic sum of those moment only will give you a bending moment of that diagram. Okay, so the shear force diagram, why we are drawing is to decide the principal stress, and also when you are constructing a RCC structure, to decide the spacing of the stirrups, the shear force is very important. And in case of bending moment, it is to determine the cross section dimension, because based on the maximum bending moment only we will decide the size of the element itself, and also the position of the steel in the RCC structures, and the number of steel reinforcement also will be based on the bending moment only. So these both factors are very important, as it is the basics for the RCC structures. And other than that, some points are very important. That is, now we saw shear force and bending moment. No, the rate of change of shear force will be equal to your intensity of the loading. So this is very important. That is, rate of change of shear force will give you loading. The same case, the rate of change of bending moment will give you the shear force. Okay, so these both factors are very important. And another one important point is, when the bending moment is maximum, it means the shear force is 0 or the sign is changed, that is from positive, negative or somewhere. So the point will be 0. Okay, so at the 0 shear force point only you will be having the maximum bending moment. And this point, no, it is called as the point of contraflexure. So which point means where the bending moment sign changes and is equal to 0. Okay, so where the bending moment is equal to 0, that point is called as point of contraflexure. So these 4 points are very important. The one is rate of change of shear force is equal to loading, the rate of change of bending moment will be equal to shear force, and the point of contraflexure is the bending moment is 0 and the shear force is 0, means the bending moment is maximum there. Okay, so based on these concepts, let us see the type of loading and the shape of the shear force and bending moment. So this is also an important thing, because they have asked this in the objective questions. So they will be giving this type of loading, means what will be the structure of the shear force, like that they will be asking. So these 5 points are very important. So first, let us see about the point load. So point load means it's nothing but if it is a simply supported beam like this, and if you are having a point load like this, means the shear force variation will be rectangular. Okay, so how this varies means it will be like this shear force diagram. will be like this. Okay, so this is how the shear force diagram looks. So the variation is of rectangular shapes, that is only given as rectangle. Then how is the variation of the bending moment? So it is inclined line for the linear. So how this occurs means it will be like this. So this will be a bending moment diagram for this shape. Okay, so this means that the point load is applied means the variation of shear force will be rectangle and the variation of the bending moment will be inclined for the line for linear. And the next is UDL. The same, if you take simply supported, and UDL means a variation of shear force will be linear and the variation of bending moment will be square parabolic. So this is very important. UDL means itself it is parabolic only. Bending moment diagram will be parabolic only, and specifically it is a square parabolic. The third case is UVL. UVL means it is uniformly varied load. Okay, so it will be like this. You'll be seeing this type of loads. No? So this is called as uniformly varying load. For this, the variation will be parabolic. Shear force will be parabolic and bending moment will be cubic parabolic. Okay, and then the next type is parabolic load. So when the parabolic load is applied, the variation of shear force will be cubic. Okay, so this is only for this point and this is for this point. So it will be cubic and the variation of bending moment will be 4th degree polynomial. Okay, and if the bending couple is applied in any simply supported or fixed beam, something means the shear force variation will be nil there. No shear force variation will be there because only the bending couple is only applied. There is no other force applied there. Okay, so there will be no shear variation and the variation of bending moment will be vertical step at that point of application. So it is nothing but where the moment is applied. No, so at that point the moment will be stepping down like a rectangular box or something. Okay, so this is the different shapes of the bending moment and the shear force for various types of load. So this tabular column is very important and you should be thorough of this because this is directly asked in the objective, and also the loads will be giving and the diagram will be given as the option, so we can choose the diagram which is equivalent to that loading. So that if that is given means when a UDL load is given, you should know that the parabolic should be drawn there like that. Okay, so that is also important. So you can remember like this. So it will be alternatively given. The first point is rectangle. First you remember all these 5, that is point load, UDL, UVL, parabolic and bending couple means. Then rectangle, then these both will be linear, then these both will be square parabolic, then these both will be cubic parabolic, and this both will be not same. And the last point is step-at point, so which is again similar to the rectangular only. So you can just remember by like this so that it will be easy for you. So now let us see some important structures and the basic structures to be known, and they are shear force and bending moment formula. Okay, so this is your shear force and this is your bending moment. Okay, so the first case they have given a fixed beam, fixed cantilever beam with a point load at its free end. So it's a cantilever beam with a point load at its free end. So here shear force means, as I told you, only the summation of the reactions. So if you take the summation of the reactions, only one load is there, so obviously shear force will be W, and the bending moment means it is W into L, so WL. In the next case, it is cantilever with UDL throughout it. So when it is a UDL, you have to convert that UDL into a single point load. So when you are converting, it is W for the whole length, no? So W into L will be applied in the middle. W into L will be applied in this middle case. Okay, so the shear force will be WL. So when you are taking half the section, it is W into L by 2. So bending moment will be WL square by 2. In the third case, it is fixed beam with central point load. So obviously it is W by 2 and then it is WL by 8. So here you may think only W is there, no, why W by 2 is given means. So always the reactions at the ends to end should be taken, no. So here the central load is W, but the two ends are fixed ends. So fixed end means there will be 3 reactions, 3 forces will be occurring. because it has 3 number of independent reactions. So when you are applying this W to there, obviously an opponent vertical force will be applied here. So force like this, reactions will be applied here. So this will be equally splitted because W is acting at the center. So here also W by 2 and here also W by 2. So the shear force is W by 2 and the bending moment is WL by 8. And the next case is simply supported with central load W. So it is W by 2 and WL by 4 is your bending moment. And UVL, it is WL by 2, WL square by 6. So as I told you in the previous cases, you can check how the shear force and bending moment is occurring. You can take either half of the section, you can take either left or right, and you can check the summation of the shear force and the bending moment, and you can check the formulas. The next case is simply supported with the load at any point. So it is not at the center, any other point other than center. So if it is this distance is A and this distance is B, means it is WA by L in the left end and it is WB by L in the right end. And then the bending moment will be WAB by L. And then simply supported with the UDL, it is WL by 2, bending moment is WL square by 8. And simply supported with the moment at any point, either A or B, the shear force will be M by L and the bending moment will be MA by L and MB by L. And UVL in a simply supported is WL by 3 in one side and WL by 6 on the other side, and the bending moment is WL square by 9 root 3. And it is a simply supported with the UVL, but this is a different form of UVL. So it's WL by 4, WL square by 12, that is the bending moment. And then it is fixed support with UDL throughout it. So the shear force is WL by 2 and the bending moment is WL square by 12 at the ends. And the center, it is WL square by 24. So why I have given center for this around means this they have asked many times in the objective questions. So this is important. So these are the basic and important structures you should be known of, and this term, so this is also called as the triangular load also. And knowing the basics of these diagrams, that is shear force and bending moment, will help you in the further steps, that is further units of this strength of materials, because based on these values only everything will be calculated. Thank you and keep watching for the next lecture on center of gravity and moment of inertia.